Welcome, ladies and gentlemen. May I have your attention, please? Thank you. Let's get going right away. So we know we can expand a product of binomials in accordance with our FOIL process, where we can consider the product of the first term, the 2x times the 2x. That would be 4x squared, the outside product. 2x times negative 3 would be minus 6x, the inside product. Plus 3 times 2x is plus 6x, and then the last plus 3 times minus 3 is minus 9. There we see it, FOIL, first, outside, inside, last. However, this isn't my final answer. We see that these middle terms, negative 6x and positive 6x, are both linear terms. They're both x to the first, so they could be combined through addition and subtraction. And by golly, it looks to me like they cancel one another out. So my final answer would be 4x squared minus 9. Raise your hand if you had that already, please. Way to go, you guys. And so we recognize that as a special, right? If I take a binomial and multiply it by the same binomial, same entries, but opposite sign, it creates outside and inside products that are exact opposite. And you're left with a difference of perfect squares. That was one of our specials from last semester. So too is number 2 a special in the sense that we're multiplying a binomial, right, by itself. This does not equal 9x squared minus 25. We can't distribute that exponent into my parentheses because there's a sum or difference. That is addition or subtraction. This is a FOIL problem, just like number 1. Number 2 is just like number 1. It's a FOIL problem. So my first step, I would rewrite this as 3x minus 5 in parentheses times 3x minus 5 in parentheses, right? This is a FOIL problem. And so now we can see, I'll use the same colors, my first 9x squared, my outside minus 15x, my inside minus 15x, and our last plus 25. We see that we have a FOIL problem. So anytime we take a binomial and square it, that is multiply by itself, the result will always be a trinomial. We're going to get a middle term here every single time. It looks like this middle term is twice, right? Twice the outside product, or twice the inside product. We've got a negative 15x from the outside, another negative 15x from the inside, so we get a total of negative 30x plus 25. And at this time, I ask that you go ahead and raise your hand if you had that already. So who had that middle term, negative 30x? Do you get it? Awesome. Way to go, you guys. What questions do you have about your binomial expansion? It's just fancy for multiplying out those two-term polynomials. Great. Let's go ahead and solve then. So if we simply have an x squared term in my quadratic equation and no linear term, no x term, then we can solve by taking square roots. This is the easiest kind. The most efficient way to solve when we have an x squared term but no linear term is to undo squaring by square rooting. And so all we'll do is add or subtract, multiply or divide to get that squaring term alone on one side. And then we'll undo squaring by considering the positive and negative square root. So this one we're not going to go and make our recipe, right? We'll just go right to it and we'll add 4 to both sides as my first inverse operation. Thanks for showing that. As I add 4 to both sides, I get x squared equals 5 plus 4 is 9. And we just have one step to go. If x squared equals 9, then I know x must be given by the positive and negative square root of 9. Sometimes this will reduce, sometimes it won't, but either way I'll have 2. I'm going to keep with the arrows to split it up, right? Not because we have operations after the fact, right? Which oftentimes we will, but rather because I want to drive home the point that there's 2 separate solutions. One of them is given by x equals the positive square root of 9, or x equals 3, and the other one, x is given by the opposite square root of 9, or x equals negative 3. Raise your hand if you have both of those. So we had 3 and negative 3. You guys are killing it. Nice. Love it. We're going to go places this second semester. I'll tell you what. This is going to be a great class. I feel it. All right. Number 4. Why can't we solve number 4 by taking square roots? We just did with number 3, and it was easy cheesy. We got 2 answers. What's different about number 4 than number 3 that means I can't solve by simply taking square roots? Go ahead and quietly tell your partner and be ready to share your response with the whole class. What's different about it?
Yeah, but isn't it because of that x?
So what is it that's different about number 4 that means we can't solve just by taking square roots? Right? Why can't we solve number 4 just by taking square roots? What's different about it? Will and Aaron?
There's a x, there's negative 4 times x instead of just the negative 4.
Absolutely. We've got an x squared term and an x term mixed together in the same problem. If we added this 4x over, like we added the 4 over in the first one to get the x squared alone, right? And then we went to undo the squaring by taking square roots, we'd have that 4x still hiding inside of a radical. So I'd have a variable x squared over here and another variable over here, x. Right? So I'd have x in two places. I wouldn't be solving for x by taking the square root. I'd still have another x floating around. Right? So I can't solve this by taking square roots. What if I left it alone and tried to take the square root right here? If I tried to take the square root right here, I'd be applying a radical to a sum or difference in the same way that we applied an exponent to a sum or difference, and that ended up being a FOIL problem, multiplying it all the way across. The same is true here. We can't go term by term and take the square root of this and then minus the square root of that. We can't do that with square roots because of the addition or subtraction. And so we cannot solve number 4 by taking square roots, right? The way that we could solve number 3. If there's a linear term, that is an x to the first term, mixed in with my quadratic equation with the squaring term, then I can't solve by taking square roots. Oh, does that mean there's no solutions? Right? Does not exist? Undefined? No real solutions? No, we certainly can solve this, and that's what we did last class. All we need to do is add or subtract, get everything on one side in standard form set equal to 0, and then see if we can solve by factoring. And that's where we spent a lot of our time, our second half of Unit 5. In fact, we were all about factoring. So my best first step is not to add the 4x over to the right, but rather to subtract the 5 from both sides, rewrite in standard form, and see if we can factor. Here we go. X squared minus 4x minus 5 equals 0. And now we'll go ahead and try to solve by factoring. So it looks to me like these are not perfect square numbers on the first and the last. 5's not a perfect square, so it's not going to be a special pattern like our expansions in 1 and 2. It's 3 terms, so I'm going to go ahead and try to undo the FOIL pattern here to see what binomials multiply together to produce this blue trinomial. So I'll go ahead and fill in my variables. Because it was x squared, I know that my firsts have to be x and x. I also know that my lasts, that negative 5x, is prime. And so my only choices for my lasts are plus or minus 1 and 5. Hey, that's easy. I can fill them in already. I know my only choices are plus or minus 1 and 5. So I can fill in my 1 and 5 already because there's no other pairs. What matters is the sign of those entries. I need to know if it's x plus 1, x plus 5, x minus 1, x minus 5, x plus 1 and minus 5, or minus 1 and plus 5. So how do we tell? Easy cheesy. We only consider the sign on the last term. If my last term is negative, I know the only choices, the only way to make that happen is if my entries in the binomial are opposite sign. Right? 1 positive, 1 negative is the only way we're going to multiply together and get that negative last from my FOIL problem. The question is which, such that they multiply to give me the negative 5, but sum to give me the squiggle underlined middle term, negative 4. So what are the signs going to have to be to make this work? Mitch? Positive, negative, respectively. So it looks like we've got x plus 1 and x minus 5. That makes an outer of negative 5x. When combined with an inside product of plus 1x, sums to give me the negative 4x. Thank you, Mitch. That's perfect. So we factored correctly. Raise your hand if you factored this correctly. Did you get to here? Great. And then it's just a hop, skip, and a jump right to the end. So long as I'm fully factored form set equal to 0, I can utilize the 0 product property. I'm going to set each individual factor equal to 0 and solve separately. Here's where I get my 2 separate solutions from. They come from 2 separate equations. One is the first factor set equal to 0. In this case, x plus 1 set equal to 0. And then the one from the second factor. In this case, x minus 5 set equal to 0, and solve separately. There may be more, right, or fewer inverse operations after the fact, depending upon what your factor is. In this case, we're a one-stepper. I can subtract 1 from both sides and get x equals negative 1. In the right side, I can add 5 to both sides and get x equals 5. And I'll go ahead and check my answers in the original. So I'll go ahead and plug in negative 1 everywhere I see an x and see if it makes a true statement, just to verify that I have in fact found a correct solution value. Here we go. Negative 1 in for x. Negative 1 quantity squared is positive 1. Minus 4 times the negative 1 is plus 4. Does positive 1 plus 4 equal question mark 5? Yes, it does. So that's a solution. And same with 5. 5 squared is 25 minus 4 times 5 is 20. Does 25 minus 20 equal question mark 5? Yes, it does. So we are confident in our solution. Raise your hand if you got x equals -1 and x equals +5. The signs matter. The signs matter. So several of you did, many of you did not. And it could have been because we started earlier. We want to make sure we're comfortable factoring. Factoring is going to be an efficient method to solve quadratic equations when we have x squareds and x's mixed together in the same problem. We cannot solve by taking square roots, right? Because of that x term. We can't solve by taking square roots. The only kind of quadratic equation we can solve by taking square roots, right? First is if there's just an x squared term and no x term next to it. Awesome. What questions do you guys have about today's Bellwork? Great. Now let's go ahead and get you credit for your second homework assignment, number 2. I'm going to pause the recording as we go over our answers, and then we'll resume after we collect. Okay, ladies and gentlemen, and so by now everybody's gone to their course registration meeting in the PAC, right, for the juniors, the sophomores, and the freshmen. And so what we would like to do is talk about current advanced algebra students as they set up for their schedule next week, okay? So if you're a current sophomore in advanced algebra, the vast majority of you will enroll for FST next year, okay? So FST would be the next course that follows advanced algebra, and that stands for functions, statistics, and trigonometry, right? That's the main sequence that follows advanced algebra, and then that would lead to your senior year taking pre-calculus to make sure you have a comprehensive foundation of math skills as you move on towards college. Another option would be if you're a current junior, right, and you're considering going to Madison College, right, the old MATC, Madison College, or any of the area technical schools, then senior algebra would be a possibility. It would allow you to earn both high school and college credit while still in high school. And so there's dual credit. There's a dual credit option. If you're a current junior and are going to take senior algebra next year, you can get Madison College credit or any of the technical school credits that will transfer them to the Wisconsin system schools, and high school math credit as well at the same time. And senior algebra is comparable in a lot of the content to advanced algebra this year. If you're a current sophomore or junior who is struggling in advanced algebra, then it's certainly an option to retake advanced algebra next year. That way you could solidify your skills and not move on, not progress on further with big conceptual gaps or lacking in skills development. And so it is certainly an option to retake advanced algebra next year if you're struggling and having a difficult time in advanced algebra this year. And there's nothing wrong with that. Another possibility is if you're a high-achieving sophomore, a very high-achieving freshman, you could apply to take the compacted course. There's a lot that goes along with that. In order to make room for 2 years of math, essentially, both FST, functions, statistics, trigonometry, and pre-calculus in a single year, some of the important discrete math topics in the FST course are carved out and eliminated to make room for the pre-calculus. And so this is certainly an option that warrants caution, okay? You don't just automatically sign up for the FST/pre-calculus compacted course. There's an application process, and you're going to miss out on statistics and some discrete math like probability that occurs in the regular FST course. It's taken out to make room for the pre-calculus concepts. Nevertheless, right, some students want to see calculus as a high school student, and if you're a current sophomore, the only way to do that then is to apply for and get into the compacted course. Again, that's reserved for very high-achieving sophomores or very high-achieving freshmen. We did have some applicants last year, but it's more difficult to get in as a freshman student because we have to make sure that there's programming and adequate programming for you than when you become a senior. If you're interested in learning more about the compacted course, then there are mandatory compacted course meetings set up not for this week, but for next week during the FlexiSched contact time, Tuesday the 9th through Friday the 12th, and the teacher is going to be taking each of those days. So I'll be on Tuesday the 9th. Mr. Marks, Mr. Aker, and Mr. Notsky will each be in charge of a session Wednesday, Thursday, and Friday. And there's a mandatory compacted meeting if you'd like to apply for that. You'll get application papers at that time, and we'll talk about some more differences between FST/pre-calc compacted versus the regular FST and pre-calculus sequence. It definitely warrants caution, but is an option for those high-achieving sophomores if that's where they want to be. And then it's possible that math doesn't fit into your schedule next year, depending upon what you're majoring, if you figured that out, and depending upon what year you are in school. If you're currently a junior, there are a few students where no math is actually makes the most sense, okay? And so if you have questions about this, please come and see me outside of regular class. I'd be happy to share what steering advice I could and send you places where you could get more information about each of these options. We will talk about this again next class. If you're interested in the compacted course, you must go to one of those informational meetings set up during next week's contact time to get the application and materials. All right, so what's up today? Today we're going to continue solving quadratic equations. We already have two methods. One of the methods we did in Bellwork, right? If there's just an x squared, we can solve by taking square roots. The other method we looked at last class, and that is if there's an x squared and an x term mixed, then we're going to solve by factoring. And so we've got taking square roots is one, right, is one method. We've also got factoring. Today we're going to add a third method, and that's called completing the square. Okay, this method's a little bit trickier than the taking square roots or the solve by factoring, but it's more powerful. So let me show you what I mean. What if the last Bellwork question hadn't been x squared minus 4x equals 5, but x squared minus 4x equals 6? All right, let's consider how we solve this. Could we solve this by taking square roots? No. Why couldn't we solve this by taking square roots? Jacques? Yeah, we've got an x squared term and an x term, right? They're not like terms, so we can't combine them. If we added over the 4x to get the x squared alone and then took square roots, we'd still have an x hiding inside the radical. If we took the square roots right now, we can't distribute the radical between two different x terms, so we wouldn't have any way of isolating a single x by itself, which is what it means to solve. So we can't solve by taking square roots. Could we solve by factoring? Well, let's try. We've got an x squared and an x term mixed. My first step to solve by factoring is add or subtract everything one side, standard form set equal to 0, and then try to factor. So I'll subtract the 6 over in order to rearrange this and see if we can solve by factoring. So I get x squared minus 4x minus 6 equals 0. I know that 6 is not a perfect square number, so it won't be a special pattern. I'll set up my pairs of parentheses and see if we can't undo FOIL to generate the factors of this, so I can set each individual factor equal to 0 and solve separately, just like number 4 from the Bellwork. So as I go ahead and scan this problem, I know since my first is x squared, my only choices for the first entries in the binomials are x and x. I scan the last, and I know my entries for the last must multiply to give me 6, but sum to give me that middle term, the negative 4. So if I consider my integer pair of factors for 6, I've got plus or minus 1 and 6, but also plus or minus 2 and 3. Are there any integer pair factors of 6? No, that's it. So which of these integer pair factors, 1 and 6, or 2 and 3, would I have to choose so that they sum to give me the negative 4? What's the problem here? Okay, what's the problem here? Blake?
No, there are none.
There are none. 6 and 1 don't sum to give me 4. 2 and 3 don't sum to give me 4. There's no combination of these, one positive, one negative, right, such that they sum to give me that middle term. And so this is not solvable by factoring, and yet there's still two solutions, right? And we can find them not by taking square roots, not by factoring, but by our third method for solving quadratic equations, and that's called completing the square. This option then, completing the square, this method is appropriate when we have x squareds and x terms mixed, but I don't recognize the factors or I can't factor. And so today that's what we're going to do. The next couple of slides is going to set up a pattern that will allow us to generate a new method for solving quadratic equations, and that's called completing the square. It'll allow us to rewrite that in such a way that we could solve by taking square roots. Let's go ahead and take a look at first squaring these binomials. And so we're going to do one together to remind you, and then you and your partner are going to complete the rest. I'm going to ask that you come up and share your answers on the board. So let's take a look at these binomials. If I wanted to square x minus 2, right, x minus 2 quantity squared, recall that means x minus 2 times x minus 2. This is a FOIL problem, where my first product is x times x is x squared. Where my outside problem is x times negative 2 is minus 2x. Where my inside product is negative 2 times x is Negative 2x, and my last is negative 2 times negative 2 is plus 4. And so if I were to expand, that binomial squared in number 1, the final result in all of these will be a trinomial. In this case, I get x squared minus 2 for 4x plus 4. Okay, with your partner, I want you to go ahead and expand 2 through 5 and make sure that you box your final answer so I can see at a glance. Some of you already have some of them done. That's great. I'm going to ask that you come and share your response on the whiteboard. Each of your answers for these should be a trinomial. That's a 3-term polynomial because you're doing a FOIL problem. You're multiplying a binomial by itself. Always going to get a middle term there. As you get towards the end, number 4, number 5, see a pattern developing, right? That can save time and energy, and that's going to be a key point in our process so we can complete the square. All right, go ahead and share your response with the whole class when I call on you. Get ready. Everybody check out your number 2. All right, number 2. What did you get for your final answer? We'll go right to the final answer for number 2. Kenzie?
X squared plus 2x plus 1.
X squared plus 2x plus 1. Raise your hand if you had number 2 correct. Number 2 correct? Good. Please share number 3, final answer. Hannah. X squared plus 10x plus 25. Raise your hand if you have the same as Hannah. Number 3. Awesome. Thanks, hands down. Number 4, final answer. Samantha?
X squared minus 6x plus 9.
X squared minus 6x plus 9. Raise your hand if you had the same as Samantha. X squared minus 6x plus 9. Good. And we're seeing kind of how those original binomial is comparing with my entries in my final trinomial. And then lastly, x plus 7 quantity squared. What's that going to give us, Maya?
X squared plus 14x plus 49.
X squared plus 14x plus 49. Everybody go ahead and raise your hand if you have perfect score on this. Who got them all right? All right. Good. Everybody look at my original entry. My original entry in my binomial. What does this positive 5, right? That positive 5 have to do with the positive 10, that middle term. What does this minus 3 have to do with this minus 6, the magnitude of the middle term? What does this plus 7 have to do with this plus 14x, the middle term magnitude in the trinomial, right? What's the relationship there? Nathan Z?
The last term is multiplied by 2 to get the middle term.
The last term in my original binomial entry is multiplied by 2 to get that middle term. 5 times 2 gives me the 10. Well, if I double negative 3, I get negative 6. If I did 7x plus 7x, I'd get 14x. And so the magnitude of the middle term of my trinomial is always twice that of the last term of my binomial. Nice. How does the original, right, last in my binomial compare with the squiggle underline last? How does 5 relate to 25? How does negative 3 relate to 9? How does positive 7 relate to positive 49, right? What's the relationship there? Go ahead and share with the class when I call on you. Ian? It's multiplied by itself. That came from the last, the L in my FOIL, right? The last product comes from the last entry times the last entry, so 5 times itself is 25. Negative 3 times negative 3 is positive 9. Positive 7 times positive 7 is positive 49. In fact, that last is always going to be positive, all right? This is an important pattern because we're going to complete the square in order to solve these quadratic equations. So for your next slide, I want you to go ahead and see if you can't reason out, right, what my last entry would have been in my binomial based on my middle term. I know my variable, right, has to match, and so an n squared must have come from an n. But I have to decide on what my last entry would be in order to square this and produce a 12. And so how do they relate? Well, Nathan told us my middle term was double my original binomial entry in the last. So this 12, if it were double my original binomial entry in the last, then this must have been a 6. The sign of my middle term must match the original. So if it was x minus 3 quantity squared, I got a minus 6x. If it was x plus 5 quantity squared, I got a plus 10x. Is this one a plus 12n or a minus 12n? Well, it looks like plus, so this must be plus. And then Ian told us that our last came from taking our entry in the binomial and multiplying by itself. And so 6 times 6 equals 36. Can you see that the trinomial n squared plus 12n plus 36 is the binomial n plus 6 times itself, quantity squared? Go ahead and complete 7 through 9 with your partner and be ready to share. So this one I want you to do with your partner now. See if you can go backwards and figure out what it has to be. Both with parentheses squared and with the missing blank.
I just got it right here.
Essentially, it's the square root of the second.
I guess. Yeah, I know there's too.
Awesome. Some of you are in different places, right? Let's go ahead and share then. Let's fill in the blanks. So let's go ahead and fill in the blanks. On the right-hand side, we're always going to have something squared. Okay, we're always going to have something squared. I'll be calling on you to help me fill in the blank of the trinomial as well as this binomial complete with the operation. So please be ready. X squared minus blank plus 25. You can do it in either order. What am I going to have to square in order to get that 25 there? What am I going to have to square to get that 25? Casey?
5.
Good. So this is going to be 5 here. My variable will be x. And what sign will I need here so that I get a negative in the middle? You guys see that negative there? Right, so what sign am I going to have here? Jacob? Good job. So who had x minus 5 squared? X minus 5 squared? Good. Which means my blank is going to have to be what? Right? What's going to have to go in my blank? Will? 10x. Awesome. So raise your hand if you had minus 10x for your middle term. Way to go. Okay, go ahead and then fill in the blanks for number 8. So what did you get for number 8? X squared plus 6x. And Chloe? 9. Awesome. Which means this must have come from what? Quantity squared. Chloe? X plus 3. Raise your hand if you had the same thing. 9 and x plus 3 quantity squared. Great. Let's go ahead and do the last one then. So my last one, that middle term, wasn't even like 12 or 10 or 6. It was 9. That's no problem. You could take half of 9, right? Many of you took half of 9 and used 4.5 and then squared it to get 20.25. And that's fine, but I'm going to stick with fractions. I'm going to go ahead and do half of 9 and get x minus 9/2. I'll just leave it as 9/2, which is 4.5. Quantity squared. Whoops. Got a little excited. Got a little excited there. Love math. Seriously, love math. Which means that my last entry would have been 9 squared, right? Would be 9 squared times 9 squared. I'm sorry, 9/2 times 9/2 is 81/4. And that's where you're getting your 20.25 or 20 1/4. So I'm going to go ahead and call that 81/4. You may leave it as 20.25. What questions do you guys have about our pattern, our squaring a binomial pattern? Great, because that's how we're going to solve by completing the square. Let's go do one together, and then we'll come back and get our strategy for completing the square, and then we're going to practice with another couple. So here we go. We're ready to solve now. Let's isolate the x terms on one side, so the x squared has a coefficient of 1 to set up for completing the square, what we just did on the last page. So you guys already completed the square over here on the left-hand side. Let's go ahead and see what that looks like in the context of solving an equation. So here we go. As I solve this by completing the square, I first want to add or subtract and get all the x's on one side, everything else on the other. So unlike our solving by factoring, where our first step was to subtract a 3, we want to keep these x's alone on one side and move everything else to the other. And so in this case, I want to leave those x's on one side, and I'm going to move everything else to the other, and that's why my best first step is to subtract 11 from both sides. So now we'll subtract 11 from both sides. This gets our x squared minus 6x alone on one side. I'm going to leave some space now to set up for completing the square. It's going to be like filling my answer blank, like you guys just did on the previous slide. We're going to complete the square by figuring out what special number we need to add to each side. Meanwhile, back at the hacienda, on the right-hand side, I have 3 minus 11, which is negative 8. So I've gone ahead and I've added or subtracted, right? I've added or subtracted to get the x's alone on one side with the leading coefficient of 1 and everything else on the other. Now I'm going to go ahead and add an amount to the x side to make a perfect square trinomial. What? I'm going to figure out what completes the square. I'm going to do what we did on the last slide. I know the relationship between that middle term in the trinomial, right, is exactly double. It's double whatever that quantity in my original binomial is. And so if I wanted to figure out what I'm going to add to both sides, I simply need to take half of that middle term and then square it to see what will complete the square. Half of 10 is 5, and then squared is the 25. Half of 6 is 3, and then squared is the 9. In the solving example, half of negative 6 is negative 3, and then squared is what? 9. So what am I going to add to both sides? 9. I'm going to add a plus 9 to both sides to complete the square. So I considered that middle term. It was negative 6x. Half of that would be negative 3. And then squared is always positive, in this case, plus 9. That's what I'm going to add to both sides. And so I've gone ahead and completed the square by considering what half of the middle term is and then squaring it. Half of negative 6 is negative 3, and then squared is 9. Now we're going to go ahead and rewrite this trinomial as a binomial squared. That is, what binomial multiplied by itself equals x squared minus 6x plus 9? Well, we just did that, didn't we do? We did x squared plus 6x plus 9 came from x plus 3. This one is x squared minus 6x plus 3. So what must my binomial entries be? Right? What would have to go in here? Mark?
X minus 3.
X minus 3 is correct. X minus 3, in fact, is equivalent to, quantity squared, is equivalent to x squared minus 6x plus 9. If I FOIL that out, I'd get the squiggle underlined trinomial. Right? We just did that on 2 pages. You FOILed out a binomial, multiplied by itself, and you got that trinomial. We're just going backwards. We're figuring out what that came from. On the right-hand side, I'll simply combine like terms. Negative 8 plus the 9 I added to both sides to keep it balanced equals positive 1. So we've completed the square and rewritten that trinomial as a binomial squared. Now guess what? A single x term. I no longer have an x squared and a separate x floating around. I have a single x term quantity squared, and now guess what? we can solve by taking square roots. And so now we'll go ahead and solve for x by taking square roots. If x minus 3 quantity squared equals 1, then x minus 3 must be given by the positive and negative square root of 1. We're going to undo squaring just like we did on the first day by taking square roots. If it's an even integer exponent, in this case an exponent of 2, an even integer exponent, I have to consider both the positive and negative square root. So now we're good at this. Now we can finish this out by breaking up into two separate equations and solving each one separately. So if x minus 3 equals a positive square root of 1, then x minus 3 equals 1. And if x minus 3 equals the negative square root of 1, then x minus 3 equals negative 1. And I can solve separately. It looks like x equals, in the first case, 1 plus 3. I'm getting 4. In the second case, I'm getting negative 1 plus 3 is 2. I'm getting 2. Let me check in the original. So if I put 4 in the original, I'd get 4 squared is 16. Minus 6 times 4, that's minus 24. 16 minus 24 is negative 8. Negative 8 plus 11, does that equal 3? Negative 8 plus 11 does equal 3. In the second case, x equals 2. Into my original, I get 2 squared is 4. Minus 6 times 2 is minus 12. 4 minus 12 is negative 8. Negative 8 plus 11. By golly, that equals 3 too. So we found our solutions, and we've done it by taking square roots. But the reason we could take square roots is because we used completing the square to get there. We used completing the square to rewrite this that had an x squared and an x term in order into a single squaring term where we just had a single x in their quantity squared. That's the power of completing the square. And now, even though we couldn't factor that, now we can solve this. So that's pretty sweet. Well, this one we could factor if we rearranged it, but sometimes we won't be able to when we have radicals. Let's see what other ones we can do. So can we get our strategy? Dun, 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 dun. How do we determine the specific amount to add to both sides of the equation to complete the square? And so what did we do here when we set up the pattern? We took half of the middle, right? Half of the middle. Half of 12 is 6, and then squared is 36. Half of negative 10 is negative 5, and then squared is positive 25. Half of plus 6 is plus 3, and then squared is 9. So what can we do? Well, we'll take half of 4 is 2, and 2 squared is 4. So plus 4 would be the first one, if we were going to do that in some problem. We're not solving it, we're just practicing getting on. Half of negative 8 would be negative 4. Negative 4 squared is plus 16, so we'd be adding 16 to both sides. X squared plus b, x squared plus bx. What would I do to get that last, that I add to both sides? Well, we get half of negative 8, right? So I took negative 8 divided by 2 and then squared it to get 16. I took half of positive 4 and then squared it to get 4. What am I going to do here? I'm going to take half of b, that's b divided by 2, and then square it. And so we can generalize this by taking whatever my middle coefficient is, dividing by 2, and then quantity squaring it. So how do we get that special number to add to both sides? We divide the middle term by 2 and then square the result. So we divide the middle term by 2, enter, and then square the result. Sweet. Let's go ahead and try another. So, x squared plus 8x minus 8 equals 12. And remember, right? We've got an x squared and an x term mixed in, so we can't solve this by taking square roots. Now, we may or may not be able to solve it by factoring. In the first one, we could have solved by factoring, but we won't always be able to. Completing the square will always work even if we have an irrational answer. So let's go ahead and practice. My first step here is not to subtract the 12 over and set equal to 0. Rather, it's to isolate the x terms by adding over 8. So everybody please do that. My first step here would be add 8 to both sides. And now I'll get my x's along one side and leave space. So x squared plus 8x leaves space for completing the square. So I'm going to scooch up some space over there. Equals 12 plus 8 is 20. So we're leaving space there for that special number that we're going to add. Remember, we can get that special number by dividing my middle term, my middle term's coefficient by 2, and then squaring the result. Go ahead and decide with your partner what special number you're going to add to both sides, and then be ready to share with the class when I call on you and your partner. What are you going to add to both sides here? What's going to complete the square? What's going to complete the square? All right, so go ahead and share with you and your partner said. All right, what did you and your partner say? Joe and Chloe? 16. Raise your hand if you're going to add 16 to both sides. Who's going to add 16 to both sides? Yes! Half the middle term, right? And then square the result. Half of positive 8 is positive 4. Square the result is plus 16. Good job. So we've added that special amount to both sides. We've kept the equation balanced, but now we recognize this as a perfect square. This is a perfect square trinomial. What binomial times itself equals x squared plus 8x plus 16? Well, what would I have to put inside my parentheses here? Right? What would I have to put in here? Rachel? X plus 4. Good job. X plus 4 quantity squared equals that big trinomial x squared plus 8x plus 16. Nice job. Meanwhile, on the right-hand side, we simply combine like terms. 20 plus 16 is 36. You guys are doing great. Now, we have a single x term, quantity squared. Now we can solve by taking square roots, because I don't have an x squared and a separate x. I've just got a single quantity x plus 4 squared. So let's do it. If x plus 4 quantity squared equals 36, then x plus 4 must be given by the positive and negative square root of 36. Sometimes this will reduce, sometimes it won't, but either way I'll be able to break it up into two separate equations now. So on the one side I'll have x plus 4 equals the positive square root of 36. On the other side I'll have x plus 4 equals the negative square root of 36. Sometimes this will reduce, sometimes it won't. If this had been 35, I would just leave this as root 35 and negative root 35. In this case, it does reduce. The square root of 36 is 6. The negative square root of 36 is negative 6. And so in this case, it does reduce. And I can solve separately. 6 minus 4 is 2. Negative 6 minus 4 is negative 10. And I'll go ahead, before boxing, do a quick check in the top. And so I'll do 2. That'll be an easy one. 2 squared is 4. Plus 8 times 2 is 16. 4 plus 16 is 20. Does 20 minus 8 equal 12? Yes, 20 minus 8 equals 12. So that's good. I'll do a quick check with negative 10. Negative 10 quantity squared is positive 100. Plus 8 times negative 10 is minus 80. 100 minus 80 is 20. And 20 minus 8 is 12. And so both of these work. So it turns out that this was also factorable, but they won't always be factorable. And right now we're practicing the process. And so we've got add or subtract to get the x's on one side. Bless you. Everything else on the other. Then go ahead and figure out the special number that you'll add to both sides to complete the square before rewriting as a binomial squared and then solving by taking roots. Rachel?
How do you know when to use the 0 method and when to use this one?
Do you mean the solve by factoring method?
Yeah, that's
Yeah.
the one.
When you set each rate equals 0 and solve separately? I always try to solve by factoring. The zero product property method, I would normally subtract the 12 first, set equal to 0, and see if I can factor it, because for me, that's easier to solve by than completing the square. However, if I'm unable to solve by factoring, then I'm going to add that 12, whatever number now I get, I'm going to add that right back over, and then solve by completing the square. And so, how do you know which is better? I always try factoring first, because it's quicker for me. And if I don't recognize the factors or it's unfactorable, then I'll do this last method. Right now I didn't try to solve by factoring because I want to practice the new method that we're learning. And then on tonight's worksheet, worksheet number 1, you're going to be able to pick. Okay, so you're going to be able to pick which method to use based on what the problem looks like, and that's what we're getting at here. Great question. So how do you know which method to use? That depends. I always try factoring because it's easier for me, and if I can't factor it or don't recognize the factors or it's not factorable, then I'll do complete the square. All right, so let's go ahead and complete the square. I want you to go ahead and add or subtract to get everything on one side. Nope. I want you to subtract that 4 over to get the x's on one side, right? Because we're going to solve by completing the square. So we'll go ahead and subtract the 4 from both sides. To rewrite with leading coefficient of 1x squared minus 6x. Scooch, leave space. Now we're going to go ahead and complete the square. Yes, that's right. We're going to find that special number that I'm going to add to both sides, right? That I'm going to add to both sides so that I can rewrite that left side as a binomial squared. Okay, be ready because I'm going to call on you. We've done a couple of these now. Get ready. Figure out what special number you're going to add to both sides, and I'm going to call on you. So what special number I'm going to add to both sides here? Hans?
9.
9. Raise your hand if you're going to say 9. Add 9 to both sides. That's right. Good job. I take half of the negative 6 is negative 3, then I square it and get a positive 9. 9 is what I'm going to add to both sides. That keeps the equation balanced, but more importantly, it allows me to write this left-hand side as a binomial squared, right? On the right, I combine like terms and I get negative 2 plus 9 is 7. But what I'm more interested in right now is what I'm going to put in the parentheses. So please be ready to share with the class. What am I going to put in parentheses so that when I FOIL that, I would have gotten x squared minus 6x plus 9. What's going to have to go in there? Kendall?
X minus 3.
X minus 3. Good job. And now I can solve by taking square roots. I can undo the squaring with the single x term, quantity squared, because I don't have a mixture of x's. I don't have more than one kind of x in the same problem. So we'll go ahead and undo that squaring by square rooting. I know that if x minus 3 quantity squared equals 7, then x minus 3 equals plus or minus square root of 7. This is an example of one that does not reduce, right? I could not solve this by factoring. I have to use completing the square as my method for solving this one at this stage. So sometimes it will reduce, sometimes it won't. In this case, it doesn't. But I can still solve by breaking it up into 2 separate paths. In one path, x minus 3 is set equal to the positive square root of 7. What's that? That's positive square root of 7. In the other case, x minus 3 is equal to the negative square root of 7. What's that? Negative square root of 7. I'll just leave it like this. This is exact. Don't go and change it to a decimal unless you need to do something with it at the very end. Leave it exact. Once you change it to a decimal, you start sacrificing accuracy. So leave it as radical 7 and negative radical 7. My final answer, I'll get simply by adding over the 3. And so for this one, I'll add over the 3 and get x equals a positive 3 plus the root 7. In this case, I'll actually get x equals the positive 3 minus the root 7. So in each case, I've left it exact. I've added over the 3 to get positive, but I leave this sign here. My final answer would be 3 minus root 7 and 3 plus root 7. Some of you might have written root 7 plus 3 and negative root 7 plus 3, and that's correct. It's just typical math manners. Put the rational part before this irrational radical part in addition or subtraction. And so in the back of the book, you'll see 3 plus or minus root 7, right? You'll see the rational part 3 before the radical part, the irrational part. So I go ahead and practice doing that now. What questions do you have on this third one? Okay. That's for printing. So I want to go ahead and iron out Rachel's question. Rachel asked earlier, so when do you know which method you're supposed to use? So what I want to do is consider the most efficient method, and that's what our worksheet's going to be about today. When is it most efficient to solve by taking a square root? That is, without having a complete square. When can you solve by taking a square root directly? Well, that was like number 3 in our ball, right? In order to solve by taking square roots directly, we could not have an x term mixed in with the x squared. So if I only have an x squared term, then I can solve by taking square roots right away. And so, when is it most efficient to solve by taking square roots? When b equals 0. That is, there's no linear term in my quadratic equation. There's no x term. It's just an x squared. Right? It's just an x squared floating around, and I can undo that squaring by taking square roots. When is it most efficient to solve by factoring? When is it most efficient to solve by factoring? Well, when b doesn't equal 0. That is both a linear and quadratic term. That is an x term and an x squared term. And I recognize the factors. So if there's an x squared and an x in the same equation, I'll go ahead and subtract over and set it equal to 0 and try to solve by factoring first. So if I got x squared and x mixes, I always try to solve by factoring next. When is it most efficient to solve by completing the square? And to solve by completing the square, that's when I've got an x squared and an x term that is both a linear and quadratic, but I can't factor, right, or don't recognize the factors. Then I'm going to go ahead and solve by completing the square. So I kind of use that as a last resort because I like factoring. So b doesn't equal 0. So both linear and quadratic quadratic terms but can't factor because either you don't recognize the factors or it's unfactorable. And so we've seen that in the case that we rearranged our Bellwork to x squared minus 4x equals 6. Suddenly we couldn't solve by factoring. Then we have to use completing the square. Awesome. So we'll go ahead and kind of use this as our now not factoring flowchart like Unit 5, but now our solving quadratics flowchart. First, if there's just an x squared term only and no x term, solve by taking square roots. Second, if there's both an x squared and an x term, go ahead and put it in standard form and see if you can't factor. Set it equal to 0 and see if you can't factor. If you can't factor it, then go ahead and add it over to get the x squareds and the x's on one side, everything else on the other, and then complete the square by adding that special number. All right, let's go ahead and close it out for today then. If x squared equals 14, then x must equal ... Don't say it out loud, just write it down. We've got two different possibilities. The number 2, if absolute value of 2x minus 3 equals 7, then 2x minus 3 must equal, again, we've got two possibilities. When there's a non-zero linear term, why can't we solve by immediately taking a square root? And lastly, let's solve by completing the square. So we'll go ahead and get a written response for each of these, and then be ready to share with the whole class. I'd like to check with your partner, and that's fine. I want to make sure you guys are listening. Okay, go ahead and share your response with the class when I call your name. If x squared equals 14, then what must x equal, right? What must x equal? Caitlin?
Positive and negative square root of 14.
Nice job with the two solutions. Raise your hand if you had positive and negative square root of 14. Good job, you guys. If absolute value of 2x minus 3 equals 7, then 2x plus 3 must equal, well, one of two things. Aren't there two numbers that are given distance of 7 steps away from 0? Yes. One of them is 7, right? But what's the other one? Joe? Negative 7, absolutely. Raise your hand if you have 7 or negative 7. 7 or negative 7 are the two numbers, absolutely, that are a distance of 7 steps away from 0 on the number line. When there's a non-zero linear term, why can't we solve by immediately taking a square root, right? Because we've got more than two x's in the problem, right? And we can't solve for both x's at the same time by doing a single inverse operation. So we've got more than one x in the problem, more than one x term. More than one variable term. So the single inverse operation of square rooting is not going to undo each of those x's and get it by itself. All right, we're one to go. Let's solve for x. And so we know that we could get everything on one side and try to factor. It's just that there's no integer pair factors for 22 that sum to give me 10, right? 11 and 2 get me close, but they wouldn't get me to 10. They'd get me to 9 or to 13. And so this is one where we have to solve by completing the square. So let's go ahead and subtract over the 10x so that we get all the x's on one side and everything else on the other. For us, that becomes x squared minus 10x. Leave space, bless you, equals negative 22. Next, we'll consider the special number that I'll add to both sides. Be ready, because I'm going to call on you to share. I get my special number by considering the magnitude of my linear term, half of it, and squaring it. So what am I going to add to both sides here? What am I going to add to both sides here? Megan?
Adding 25.
25. Nice job. And so plus 25. Plus 25, and then rewrite my trinomial, my perfect square trinomial, as a binomial squared. Meanwhile, on the right-hand side, I'll simply combine like terms. And so, whoa, got blue dot's happy to be joining our party. Negative 22 plus 25 is 3. But more importantly, inside of my binomial, quantity squared. What? Quantity squared equals x squared minus 10x plus 25. Hans?
X minus 5 squared.
X minus 5 quantity squared. Nice job, Hans. Thank you. So now we're ready to solve by taking square roots. Now we have a single x term, right, in my quantity squared. So now I can solve by taking square roots. So we'll go ahead and break that up. I know that, well, should I do one step? I'll do one step. I'll do, if x minus 5 quantity squared equals 3, then x minus 5 equals plus n minus square root of 3. Sometimes that'll reduce. Sometimes it won't. In this case, does it reduce? No, I'm stuck with a positive radical 3 here. And I'm stuck with a negative radical 3 here. No problem. We can still solve by adding over 5 in each case. So I get two solutions. I get positive 5 plus root 3. And I get x equals positive 5 minus root 3. This is an exact answer. If I wanted to get a decimal approximation, I just go to my calculator and change this into 5 plus root 3, enter. It would give me about 7.24 something, ... right? And that's great. But I'm going to leave it exact because once I change it to a decimal, I sacrifice accuracy. If I wanted to know what this was as an x-intercept, then I change it to a decimal so I can see about where that is. Awesome. What questions do you guys have about your closer today? Then we've got a two-pronged assignment. Your assignment number 3 includes worksheet number 1. Please do that first. When you're done with worksheet number 1, you're going to go ahead and work on just 6 book problems. And so we have a short book assignment because your worksheet, right, I want you to do first, that's longer, and then 2 reading questions. While you're doing your worksheet, I'm going to stop the recording and save it to our Moodle.